Okay. Hi, everybody. My name is Anthony Urbina. I built a real-time full-stack web application for VFriends enthusiasts who want to play compete and collect online with their friends. And so, yeah, wait, okay. Wait, can we see my screen? Okay, cool. Okay, so yeah, just quick run through of my app. After we sign in, we enter the lobby. I have two tabs open because they're two separate users, by the way. So we're gonna view online players. We can see all players who are currently on the domain. Right now, we can see that Dev is on the domain, so we're gonna click his name. It's gonna send him an invite. Here we can see that you've been challenged. Anne has challenged you to a game, and Wolf, yeah, you have challenged Dev to a game, waiting for the response on one screen. And so on this user, we can either accept or decline the invite. We'll decline it just so we can see what that looks like. Sorry, Dev declined your challenge, probably scared of you. We can close that, and then if we want, we can send another challenge, which we can accept. And this will put us into a lobby where users can, play. You can flip a card. Other user can see your card flip. Now I can flip a card, and the winner gets decided. If you win, you take both cards, and you pretty much just keep running that until somebody has no cards left and the game ends and winner gets decided. But yeah, that's pretty much the run through of the app, I guess. I'll hop into the code. Okay, wait, no. Yeah, so okay, yeah, I'll just jump into the code. The feature that I'm going to be presenting is a user can accept an invite to a match and join a game, which was, hang on, I guess let me preview the feature really quick. It's this feature. You accept the match, and then you get thrown into a game. So let me drag this Zoom stuff off of my screen. Okay, so we start off in the lobby component. Okay, yeah. So when the user clicks the accept invite button, their socket emits a invite accepted request or invite accepted event to the server, passing along an invite info object that contains information about the match. For example, who's sending the invite, who the invite is to, and the room ID, which is the location of the match. And so now that we've broadcasted that event to our server, here we can see that we have a socket instance listening for the invite accepted event. Here's our invite info object. We're going to go ahead and destructure a few properties from it and create a game. So pretty much when a user accepts an invite, that's the signal that we get that both users are ready to enter a match. So we can pretty much go into state creation of the game on the server side, of course, because we don't want clients to have any control over that. So we call our create game function, pass it the challenger username and the opponent username. This should have a better name, opponent username. So let's go down to the create game function. Here we call our get deck method, which should be right here. I have these cards in physical. So I did all the data input one by one. Pretty much just an array of objects representing cards. And I wanted to map through these to get the essential properties, which are pretty much just name and score. That's all that we're going to be needing for our game. Return filtered deck, which is just an array of the base cards that we need. So that gives us our deck. We're going to go ahead and pass that to a imported Lodash shuffle function, which is shuffles our deck for us, returning a shuffled array of cards. And so next, we're going to create our players array, which is comprised of two objects representing each player, both with a name and deck property. Deck is an array that will fill with the objects of cards. And then, so once we have our shuffled cards array and our players array, we can go ahead and pass those to dealer, which will select 26 cards from the shuffled array of objects and assign 26 to each player. And so now that we have that set up, we can go back up to where the invite got accepted. Now we have our players block loaded, ready to go. Now that they have their cards, we create a room ID out of the challenger username and opponent username. Man, this name really bugs me. I don't know why I did this. Opponent username, and we're going to join those and create the room ID, which is done on purpose because in my game or in my app, usernames are unique. So pretty much like if I'm in a game with somebody else, it's like pretty much impossible for somebody else to have the same room ID because they can't share my username. So yeah, so then we create like pretty much the boilerplate state that both users are going to need to start off the game. And so we're going to stringify that, create a new row in our database under the games table representing the game that's about to start. We're going to store the challenger ID. We're going to store the opponent ID. We're going to store the state, and we're going to initialize an is active column, setting that to true, letting us know that the game is ongoing. Then we are going to make our database query, pass it our SQL code, pass it our params. Then once we know that that's successful, we're going to emit a socket event opponent joined to the challenger, letting them know that, hey, somebody accepted your invite. So yeah, now let's go back and look at that on the client side. Here, we're listening for the opponent joined event. So once this gets triggered, we step in, destructure the room ID from the invite info object, get rid of the modal that was on the user screen, and then change the window location hash to the room ID, which will change our component over to component did mount. And okay, by the way, I glossed over something. So now that's the person who sent the invite, the challenger. They're switching into the new component where the other user already is. As you can see here, when they accepted the invite, we did the same thing. We changed the window location hash to the room ID. So now they're both in the competition room and in the component did mount during the first render, trying to get synced up, loading the initial game state that we shot into the database. And so this next fetch call is pretty much just going to be trying to get them actually synced up. We want to get that data back from the database so that we could start the game. So we're going to make a fetch call to API/game/retrieve /opponent route. And yeah, let's find that in our backend. Okay. Yep, should be right here. Yeah, so we're gonna destructure the opponent username from our request parameters, and then we're gonna destructure our token from request headers. Or sorry, this isn't destructuring. Yeah, so then okay, we're gonna grab our token, we're gonna verify it, which will return the payload. Then we destructure user ID from the payload, and we're gonna go ahead and grab the user ID of our opponent so that we can make a query with it later. We're going to make that database query, wait for our result. If we don't get a result back, we let the client know that that user does not exist, and we'll send them a nice 400 error. Otherwise, we can go ahead and assign a result to the opponent ID, which is what we queried for. And then, yeah, have a lot of SQL code here. Basically just trying to get the row of the match using an inner join. You use an inner join when you have two, or sorry, not when you have two, but when you have columns that you want to merge or that you want to join that have different names but the same values. And so yeah, so that's what's going on here. Basically just trying to get the row back of the game for each player. Yeah, we're gonna make the database query, pass it our SQL code, pass it our params to avoid SQL injection attacks. Same thing here. If we didn't get a result, we want to let the client know that this user isn't in any active games, and we're gonna pass a 400 error. Otherwise, we can go ahead and pass the result back to the client along with the status 200 code. And so now that we got a response, we are going to parse that since it's JSON, and then we're going to grab the result, destructure state and game ID. We want to make sure that there actually was a state in there for whatever reason, because yeah, we need a state to start the game. So then we're going to attach the game ID to the state. let state know that we're done fetching data, and then we want to set state, and that's for both users. So yeah, they're synced up now, and that's my presentation.
All right, thanks so much, Anthony. We have about 5 minutes for questions for Anthony about his project, so feel free to unmute yourself.
How many hours do you estimate you put into this project, Anthony?
Yeah, so we had 2 weeks of final project time to make this. So like I'd say like 10 hours a day, times 2 weeks, about 6 days a week. So somewhere around 120 hours. I think for most of us it would have been that amount. Yeah.
What was your inspiration for the game?
Okay, yeah. So like going into, so the curriculum split up into 2 halves. First half is called junior side, second half is senior side. So by the time you get to the second half of the program, you're pretty much aware that you're going to have a final project. So instructors are very like on you about like, hey guys, start thinking because you're going to have a final project. And I like couldn't find any inspiration really for a project. So I started like just watching YouTube videos, like what are good final projects or what are good portfolio projects. And the more I watched, the more I was like, man, all of these are the kind of cookie cutter. Until I came across a real-time chat app using Socket.io, and I just thought that was awesome. Especially like coming from a gaming background, not professionally, but just playing games. And so I was like, man, how cool would it be if I made a game where people could compete against each other? And it was just different. I hadn't seen any tutorials of this online. Trust me, I looked. Um, but yeah, and then just had a lot of fun making it. It was really fun.
Hey, Anthony,
Thanks for the question.
Great work. It seems like a very ambitious project to take on. At one point, you had mentioned that you would not, you wanted to store the logic on the back end and not allow the client to effectively control that logic. Can you explain your reasoning behind that? I agree with the statement. I'm just curious why you would want to make that decision.
Yeah, thanks for asking. Like, I'm actually like most proud of like the fact that I did that for this project. Something that Tim used to tell us, our instructor is not at LearningFuze anymore, but he would always like drill it into us, like the back end is the app. And so like I didn't really understand that until I built this project where I mean, when you're designing a game, this is like part of game design where, okay, so like let's just say I have like a regular app where users don't interact with other users. If somebody wants to cheat, they can cheat and it'll only mess up their experience. But in a like PvP game, if somebody cheats, you're messing with somebody else's experience. So to me, it was super important to make it so that the server was a single source of authority. And yeah, because the client could lie, the client could cheat, and that could mess up somebody else's experience. So it was important to make it so that the state was a single source of authority. Yeah, nobody should be able to tell the server what to do.
Great answer. Correct. Thank you.
Thank you.
I'm curious, I noticed this was shown on your local host. What are your plans for deploying this?
Yeah, it's deployed like here. This is a fork of my final project. But this one is not as cool. Here, I'll go demo account because it's just like standard. No, I don't want to save. It's just like boring cards. It works and everything.
Still very cool, very, very impressive project.
Thank you. It won't work if I'm on 2 demo accounts, I don't think. Let's see. Oh, it works. But yeah, it yeah, it's deployed.
Okay, I think we have time for maybe one more question, if there's any other questions for Anthony. All right, well, if you have a question in the meantime, please feel free to list it in chat and we'll see about getting back to you. Otherwise, let's go ahead and move on to our next presenter. So if you wouldn't mind unsharing your screen, Anthony, that would be great, because the next presenter up is Brandon Moy. Take it away, Brandon.
Okay, perfect. I had to make sure that Zoom would minimize when I shared my screen so that we don't get an infinite loop of sharing our faces on my screen. So, hi, everyone. My name is Brandon Moy. I created Study Buddy. It is a web application for students to save and study their flashcards. I themed this application kind of around different sort of school supplies, office supplies, things like that, because I felt that the applications that I used in the past were very uninviting. They're just very, very structured, but not the way that I really felt conducive to learning. A lot of different functionalities, normal credit applications, as well as we have user accounts here. We have use this demo account. I do also have a tour function to go ahead and show the users how to navigate through my application. These different folders are the different decks that you can create. You can click on that to see the different options for adding cards, viewing your cards, studying the cards, deleting the entire deck. Inside of viewing the cards, you can see all of the cards listed here in a column. You can edit the cards, delete the individual ones, and update them. And the main feature I do want to focus on is actually going to be for my studying cards. When you choose to study the cards either from here or from the home page, it comes up with a little modal that gives you these options. This is something I didn't find on some other flashcard apps that I wanted, was that you could either go by a standard organization, you can shuffle the cards into any order, you can go by ascending order for your confidence level or a descending order. That's something I felt like I needed for myself, so I wanted to implement it in my own application. I'll just click on standard for this time being, and this is the meat of the app I want to talk about. It's going to be that you have this card here with your question on it. It's going to display the deck name, the number of questions we have, the actual question, your confidence in a highlighted streak. Clicking on it will trigger the animation to rotate over. You have the answer on the back and then your numbers for your confidence to update. Once you click that, it'll flip back over to the front side and update with the new question. I do also have a query in here so that if there is prefers reduced motion, it will not do the entire animation because I don't want to force people to sit through my animations here. And if we go into the actual code of this, one thing I do want to preface with it is that since this does not use React Router at the moment, once you load the page, we do have a component did mount that adds an event listener to the window listening for a hash change event. It then updates the state with the root running through this parse root function. And that function essentially looks for the hash root that starts with the hashtag here. It replaces it with an empty string. It splits it in half, and then it creates a new URL search params and returns this back from there. I just want to brush over that because it is important to know that's how I'm getting a lot of my information for when I send requests over to my database. So from there, we'll go ahead and look at this. This is my study options. This is what shows up on that little sticky note. The important thing here is that we do have 4 different anchor tags that essentially have that href for the study cards page. It includes a deck ID, which is passed through as a prop. And then for the special options, it also adds in parameters for your order for ascending, shuffle, and descending. Once that goes through, it goes over to that page, which is my study card page. And it passes the information through the, through the props. Cat is trying to play with me. And so from here, we go ahead and start from the bottom. We'd go into the render. It's checking to see if we, this render. It's checking if we have cards yet in the state. If we don't, we're going to go ahead and return out of the function, allowing component did mount to load our deck info. For our load deck info, it's an asynchronous function that'll go ahead and reach to the back end. I store a token in context, so that way we know that our user is authenticated, and that's how we go ahead and verify that they have access to their cards. We make our GET request, and then we send that. We will wait for the response as we make our fetch request to our API root, including the deck ID, which we get from the props, as well as the order, which we'll get from the props. To jump over to the side of what's going to be doing from there, we can see here, it hit from this end. We'll go ahead and grab that user ID. We're going to head and convert that to a number from the string, verify that it is a valid number that we have. And if it's not, we're going to go ahead and throw an error, because otherwise there should not even be a deck that exists that's less than 1 or an invalid number. I start off my SQL query with this basic structure here, and it just returns it by the standard order, which is by the card ID from which they were added. Otherwise, we'll listen to see if we have order property on a query property of the request object. And if it is equal to shuffle, ascending, or descending, we'll go ahead and change that order either by random, by confidence, which defaults ascending, or by confidence by descending. From there, we'll go ahead and insert our parameterized variables or into our query so that we avoid the SQL injection attack here. We will wait for response from our query to our database. Once we get that, we'll go ahead and grab the cards out of the rows property of a result object, and we'll go ahead and send that back. If there are any errors, we'll go ahead and catch the error. We'll throw it to our error handling function. Once we receive this back, we'll check the response to make sure that is okay. We'll go ahead and parse that response back. We'll initialize an empty string for my deck name and then grab that actually from my data if it's valid. The reason I do this is because if I don't, I could get an undefined response, and I'm not going to update my state to have an undefined value here because I do use that value to actually update the page. And once that's done, this is just a function that will essentially turn off my loading spinner modal. And then we have our catch here if there's any issues. After that, still re-render, we'll go ahead and come back through, and we'll see that we would essentially return our card study page. This is kind of the meat and the bones of the actual components that have the cards with the question and answers on it. This is just for the rest of the page to get that information. But we're passing through all of our cards as well as our deck ID, and we'll hop over to our card study page. So from on this page, we can see here, I've got just 3 functions. We've got a start flip, a finish flip, and an update confidence function. These are used in a couple places for the update confidence, but we have the start flip, which is on click on the front side of our study card. We have finish flip, which is actually on transition end event listener on our entire container. And then we have update confidence on each individual button that we use for updating our confidence. Kind of a little fun fact when I was making this is that I was running into an issue that if I just incremented my position in my cards and just updated the information, I would actually reveal the answer to the next question before I even got to show the user the question, which is kind of an issue when you're trying to study. So I came up with this sort of workaround where essentially I have that start flip, and it's just checking my state for my reveal whether I'm on question or not, and I'll move myself to halfway to the answer to the question. And that position is essentially just a transform that rotates it on the y-axis 90 degrees to make it perpendicular with the user so they cannot see the front or back side of this card. And then once that transition end starts, we'll see this finish flip function. That's going to essentially check if we're going towards the answer. We can just go ahead and reveal the answer. If we are going towards the question, we'll actually grab the length from our state cards length, and we'll grab our position and increment it by 1. If they are equal, we know that we're out of cards to go and actually redirect my user back to view all of their cards. Otherwise, we'll go ahead and set our state to have reveal back to the question side and then update our position. This information is just getting posted back in our render. We're using that just for our question and answer side of things on this end. And then we have our last part I want to go over, which is my update confidence function. This is going to be on all of those little icons which have an individual ID value equal to 1 through 5, because I only want these to really be 1 through 5, and that's how I have it setting up for those little stripe marks on my cards. When making this patch request, we'll go ahead and make an object with our confidence and the event targets ID, which is going to be that number. We're going to go ahead and stringify that into JSON when we send that into our request, and we're going to go ahead and send that fetch request. On the back end of things here, it hits my API point on this request here on this route. We go ahead and get that user ID, obviously verify that as usual. I'm also going to grab that card ID from the parameters, and then we're going to grab the confidence from the body. We're going to convert those into numbers and then confirm that they are valid numbers. If they're less than 1 or not a number, that is incorrect from the user. So I throw that right out of my function. And if the confidence is not a number, as well as less than 0 or greater than 5, I also throw that out of my function. And I specifically said less than 0 because this checking for a falsy value would also cover 0. So if I set this equal to 1, it kind of, that was just redundant. So I want to set it straight to 0. I've got my SQL here where I'm going to set that confidence equal to the first value of my parameterized query. We're going to have that card ID specific. If I don't update this, I'll update all of my cards, which would kind of be an issue if all of them are 5s or all of them are 4s without me actually studying them. And I'm also verifying that user here on that 3rd line. Once it gets through, we're going to go ahead and wait for the response from our query to the database. Go ahead and grab that updated card. We're going to make sure that it is valid. If it's not, that's going to be an issue because we don't have that card inside of our database. And then we'll just go ahead and send that response back to the user. they get that response. The response is okay. We'll go ahead and start that flip back over to the other side. And with that, that kind of finishes the entire loop of what happens when the user is studying your cards. Sorry if that was a little bit quick and talking, but can I answer any questions regarding the application or any functionality? Oh, also, thank you, Ruth. I'm glad that you enjoyed it. Just a little fun part. I did kind of theme this over my cats. So I have my little cat up here who's hanging out. He's one of the buddies. And then my other cat is the professor here who kind of teaches you how to use the application. Just a little cute Easter egg.
Very nice. Looks great.
Thank you.
You mentioned React Router. Do you have any plans to add that?
So I'm not too sure if I want to add that to this application, to be honest with you. It's something that I would want to work with moving forward. When it comes to looking back at this application, there's also a reason why I haven't converted this over to React hooks. To me, it also just kind of displays that I understand the older versions of the code or older versions of how React worked by actually using just plain state without using the hooks. I've used hooks in more recent applications as well as with like technical assessments and things like that. But I wanted this to show that if I were to end up working for a company that hasn't converted over to hooks, I would be able to utilize that. And same thing with using React Router or not.
Yeah, we have practice problems in our interview process, and some of them are classes. And so it's like, ideally our new things use hooks, but also just understanding the old stuff is a leg up.
Great job, Brandon. Are there any other questions for Brandon at this time?
I guess in that same vein, so you use context there. Do you have any experience or played around with Redux at all?
I've not yet played with Redux at all, to be honest with you. One of my other classmates from the core, he worked with Redux a little bit, and so we've had a couple of conversations about it, and just kind of talked through how it works and the functionality of it, but I haven't myself actually put it into practice yet.
So, thank you. Good work.
Thank you.
Okay, just to give you guys a heads up, I went ahead and put everybody's LinkedIn URL in chat. It's towards the top of the conversation. So if you'd like to connect with any of our presenters afterwards or learn more about them, that information is in chat for you. And since at this time, we'll probably move on to our next presenter, which is Daisy Yu. So Daisy, please feel free to take it away.
Hello, can you all see my screen?
That's good.
Yep.
Okay. Just a preference, I actually am still kind of sick. I'm really sorry in advance if I cough. I have cough drops on standby just in case. But let's see. Sorry. Okay. So my name is Daisy, and I'm going to be talking about my web application. It's called Delights by Daisy. And it's an e-commerce website that I made for cookies that I actually bake and sell myself. And so this is the homepage. And as you can see, we're actually on localhost because the feature I want to talk about today is the checkout page. And I didn't want to have to pay money to show you the checkout page. And so I have test keys where you can actually test it without having to incur any financial costs. So that's why we're on localhost, but it is fully deployed. And if you wanted to see it, it's on delights.bydaisy.dev. So we'll get started and we'll click on the order now. And I'm sorry that it's a little slow because my laptop's old. And we have 6 cookies. And then we'll start with the chocolate chip. And then as you can see, the add to basket button is disabled, and it's disabled on purpose so that you can't click it until you add a quantity. I have accordions here for actual information if anyone else actually wants to know about them. And then I'll add to the basket. Wow, my computer is very slow. I am so sorry. We're going to keep shopping, and we're going to add another cookie. We'll add this one, and then we'll go to the basket. So in our basket page, all of the cookies are shown. The subtotal per cookie and the units are also shown. You can adjust the quantities here if you wanted, and you can also remove it either this way or until you click minus until it hits 0. Then we'll proceed to checkout. And this is where we can utilize the Stripes test credit card number for a great, successful financial payment. I'm sorry, it's not normally slow. It's just Zoom takes up a lot of space on my very old laptop. Okay, so then you finally get to the confirmation page, and then it gives you a total summary of the items that you've ordered. It actually calculates sales tax, which I hard coded into the Orange County sales tax since that's where we live. And then it asks you for a confirmation email, which I use the SendGrid API for. And then once it's sent, you get a little message saying it's been sent, and then you get a button that appears saying return to home. And then just to double check, we're going to check that the email just came through, which is right here, and this is what we ordered. And so that is the email. So we'll jump into the code. We're going to be talking about the Stripe API and the SendGrid API. So as you can see on this side, this is a lot of the Stripe API actually provides a lot of the code, and I had to learn, because we learned class components first, I had to learn React hooks kind of quickly in order to integrate this properly. And then it'll check for the Stripe API key, which you have to generate as a user. And then from there, before even the checkout page is rendered, then they actually go and make a fetch request. And in that fetch request to create a payment intent on Stripe's backend server, I actually, before that, made a request to my own server with SQL. And then from there, once I get all of the cart items that the user had in their cart, I actually calculate the total amount that they would be charged for. Then I set that amount to, and then send it to the Stripes fetch request right here. And then I set it so that you can only pay with American money, USD, and then I only accept Link, which is a Stripes form of payment, and then credit card only. And then once that request is sent, I receive the client secret and the total amount that is integrated into the payment intent object. I then send it to the client side, which is over here. And then from here, then we set it into state via use state. And then since now we have value in our use state of client secret, now we're able to render this form, which actually goes to the checkout form. And then in the checkout form, we actually go into use effect, and then it looks for the client secret in the URL, which I'll touch upon later. But since it's not there, it actually returns, and then that's when you see the empty value input boxes. And then you're able to basically then make a payment. And when you submit your credit card numbers, it is handled, and you press pay, it's handled by handle submit over here. And then once handle submit handles it, I actually send a few items myself. One thing I do is I actually set paid status to true in local storage, which I use for React Router in this app, so that the confirmation page is actually protected in a protected route. And then from there, I actually let Stripe do its thing. And once the financial payment is secure, it actually returns you to a return URL. The only problem with the return URL for Stripe is that they actually put the client secret into the URL when it redirects you, and it kind of looks messy. And so what I ended up doing was redirecting the user to this process order token, which actually helps me on the server side take advantage of the client secret. I actually take it out of the URL, and then I actually send it into and save it in my database so that I can also keep track of this transaction. And then I verify where to put it with the token and the cart ID via JWT, JSON Web Token. I verify it, and then I actually take all of those orders and I move it to a new table called orders in my database, so that only orders that have successfully been paid for are now stored there. And then from there, then I actually redirect the client back to a confirmation page. And then once the confirmation page is loaded, or that's where the clients are redirected, then we actually do another request to the server so that we can actually load the page. And at this point, I actually load all of the cart items that were stored in the database into the order table. And then I actually send all of that back to the client side. And that's what we end up mapping out and then rendering into the actual order summary of the page. And then I actually calculate all of the subtotals and then totals with just like reduce and those methods. And then they had the option of, hey, can I send a confirmation email? And I did this separately because I wanted to try using two APIs. Yes, Stripe has an option to send an email themselves, but I wanted to test out SendGrid. And so from here, then once you type in your email address, I actually send another fetch request. And this fetch request will actually go into the posting of a sent email, which I thought was interesting, that emails sent via JavaScript have to be sent via HTML. And so then I had to rebrush up on how to write an email in HTML format. But I update my orders database, my table in my database, and then I actually send all of those into, and then I build those variables into my email so that I don't have to write everything else out. The thing about SendGrid is that they actually require two things. They require not only an API key, but that the email address that you're sending this email from is the same email address that they have linked to the API key, because I've tried sending it from a different email, it doesn't work. And then once those two are verified, then they actually send the email, which is right here, and then they do, and I send a it's sent response to my client. And then on my client side, once that was sent and we got a 200 response, then I actually go ahead and I remove the token from local storage. And then I also then send a set email sent as true, which is how the message pops up via use state. And then once the users actually click on return to home, that's when I actually remove the paid status that I talked about that I put in local storage earlier. And I remove that, and so that whoever is now back at home starts at a clean state. And that's basically it for the features that I want to talk about today. Does anyone have any questions?
Very cool that you're actually taking payments on here. That's pretty amazing. I'm curious, for like a public facing site, like kind of an e-com type site, if you run Lighthouse on here, and if so, do you have like any improvements that you plan to make as far as like page load and other web vitals?
So one, it actually doesn't load this slow on other computers. This laptop is very old, I'm sorry. It normally doesn't load this slow, but I actually have been researching into code splitting on Webpack so that I can actually render the code and the page faster. I tried to actually look into it and implement it today, but I didn't have enough time. And so that's something I would be working on. And then this is a project that I do want to actually finish and make it work, because I actually do sell cookies on the side. And I built this because a lot of my friends and family said, do you have a website? Can I order online? And do you ship? So the next thing that I would do is actually integrate shipping, and then so that it would calculate tax and shipping rates based off of where it already is going to, based off of the address. And so that's probably my next stretch feature.
Very cool. Thanks.
Thank you.
Yeah, it's usually ambitious to try to take on one API. You took on two. How much sleep did you get? How much?
not enough that I'm still alive.
Yeah, this is really impressive. You did a really good job.
Thank you so much.
I don't have, and you also did a really good job at explaining it all. So I don't have too many questions other than just a compliment of good work.
Thank you so much.
Can I buy cookies today or should I wait?
So I actually get this question a lot. So my background is that I actually went to culinary school. I actually was a sous chef and I'm actually switching. So I love my cookies and I worked really hard to refine these recipes, especially during COVID when I had a lot of time. I will try and make this an up and running business once I get a job because I can't do this full time and also try and make a living out of it. Cookies don't make a lot of margin. They take a lot of time. So when I get hired, I'll let you know.
What
Perfect.
you're telling me is I'm not going to get my cookies.
I mean, you
I
can
bought
make the
them this
payment.
month.
The money will go into my account. You just will not receive cookies.
All right. Well, it's a job well done. $8.
Thank you.
Nice job, Daisy. Any other questions or comments?
Hey, everybody. I just want to say thank you. I caught the tail end of that. I'm joining late, so I can't comment too much, but from the code that I did see, it looked rather clean. Great job. Great presentation.
Thank you.
Thanks so much, Eric. We appreciate it.
Oh, also, I didn't realize you actually bought some cookies. I can refund you your money.
Don't worry about it. To follow up on Eric though, I saw the tail end of Anthony's and I saw Brandon's, but you guys are doing awesome work. I'm really impressed actually. I went to LearningFuze a long time ago. And yeah, you guys are doing the whole full stack application and you're understanding it. So awesome job.
Thanks,
Thank
Taylor.
you.
It's great to have an alumni back with us.
Just saying also though, those cookies are pretty darn good. So would recommend.
Yeah, there's a lot of
Is there a pickup option?
I actually sold it via pickup option only. So when I get a job, I will make an announcement. I do have an Instagram and everything for the cookies. Like I just put it on hiatus until I get a job first.
So, well, thank you so much, Daisy. We appreciate it. All right, last but not least, it's Cameron Peck. You are on deck, so take it away, Cameron.
There we go, unmuted. Can we see my screen? Yes, sweet. Hey everyone, I'm Cameron. This is my website, LearningFuze, a full stack application for runners to track their runs. If you're familiar with Strava, I used Strava for the inspiration for the site. Back when I ran in high school and a little bit in college, we had those old Garmin watches that you had to physically hook up to your computer before the days of automatic uploading with the iPhone and everything. And so I really wanted to figure out the functionality behind how that GPX data upload worked. And that's the feature I'm going to be presenting on today. So when you navigate to my site, this is a landing page you land on. You can register through this link here. We're going to jump in through the try me out just to get going, which takes you to this My Activities page with all of the runs that you've uploaded to the site. GPS runs that you have GPX data for are shown with a little snippet from Google Maps here, whereas other runs that don't have GPX data have this no GPS found filler. Clicking on all of these pulls up information about that run. You can zoom in and zoom out, drag around the map, and it's got the path data for that run as well, in addition to the title, the date, the distance, the pace, and then the description. In addition to this page, there's a runs page that has your progress, inspired by GitHub squares, that has a green square for days that you successfully run, blue squares for rest days. Those rest days you can mess around with through this interface here. There's also a chart rendered with D3 down here, that has your runs over the past week and then any upcoming workouts. The workouts are just viewable here. Any editing for the workouts happens inside of this workouts page, which has workouts that you can add through this button down here. There's a workout form where you can check like warm up, workout, or cool down, put in information. And then once you add that workout, it'll pop up here. You can also edit these, it'll pre-fill the form and you'll be good to go. The feature we're going to talk a little bit more about today, though, is adding runs with GPX data. So that happens on this add button down here, which will take you to this add run form. If you forget your GPS data, that's no problem. You can just enter in your information normally and it'll upload a run just like that. But for today, we are going to upload a GPX run. So we'll go into my Apple Watch data and upload this run that is totally from today. definitely not from Japan 1 year ago today. That happened for this presentation. It pre-fills in the date, the distance for the run, the duration, and the pace. Then we can give it a title. We'll call this one Awesome Run in Japan, and then Totally Super Real Run during rainy season. I remember right, it was pouring during this run last year. After that, we'll click Add Run. It'll take a second because we're sending information to our backend, and then we can see our runs popped up on our activities page. So here it is. Awesome Run in Japan, the date, the distance, the pace, and then our comments. And then again, zoomable in and out and around for that run here. So that's LearningFuze with GPS data. Woo! Into the code. My app uses React Router. And so I've got all of my routes defined in here. We used hash routing during the program. So one of the first things I did when I finished was refactor it because the hash routes was bugging me. And so I refactored to get cleaner route names. The route we're going to look at for the upload run feature comes through the runs and then the upload route. So we've got this runs component. It shares a lot of information because of that run form with the edit component. So I'm using props for add and edit here so that I don't have to repeat code. Inside of our run form, to the top, we've got a bunch of imports for all of the different inputs and cards for our component, as well as the network errors and stuff like that. After that, we're grabbing the mode off of the props, whether that's add or edit. In the case earlier, we were using add. You can also edit. If we edit, that looks like this, where it pre-fills in that information. And for the GPX data, it is pre-filled grayed out. After that, we have a whole bunch of state information with use state. Someone mentioned Redux earlier for global context as well, and that's totally on my list of things to look into. After that, we take user off of use context because we're going to need that when we send a request to our backend and ultimately to store the data in the database. Entry ID off of use params if we're editing a run, and we've entered that into the URL bar, and then navigate for React Router for navigating around the page. Also a file input ref, which I'll come back to in a minute. 40, we have a use effect hook. This effect hook fills the page on page load. Inside of the dependencies array, we've got entry ID, mode, and user, which shouldn't change after the first time we visit the page. We're just checking if the mode is edit. If it is, we're calling this prefill form, which is going to grab all of the run data from our backend, fill it into state, and then fill it into the page for us. The meat of this presentation, though, comes with this handle GPX data function, which takes an event. This event is coming from the file input, which is right here. So when I click on this HTML input, it stores the file on the event.target, and then we can access that inside of our code. And I grabbed it here on line 89. The first thing we do is check if the file is bigger than 5 megabytes. That's like a huge run. For reference, a marathon is like 3.5-ish. So 5 is like 40 miles plus, like maybe a little too big for my backend to handle in my testing. And so we're just using that. If it is too big, then we clear the file input ref, let it know the file is too large, and then kick out of this function. Otherwise, we create a file reader, which is a front-end way to asynchronously read files. The reason that I chose not to send the file to the backend is because Google Maps requires the latitude and longitude data to load this image in here. And it doesn't make a whole ton of sense to parse the data and then send the file back to the backend and then either parse the data on the backend and store it if I've already parsed it on the front end, or like, do I send it back to the front end? And so instead of dealing with that, I found this file reader stuff and a DOM parser I'll talk about in a minute. And so I decided to do it on the front end instead. Most of the magic happens inside of this parse GPX data function, and we're passing in that file, that event.target.result, into that function. And so this file inside of parse GPX data, XML is a super interesting data type that I got to learn about for this presentation. It's very similar to HTML and can be parsed by a DOM parser in the same way that HTML can. So I take my XML data, which looks like this, for my run, and I'm able to go through after I turn this into a DOM tree with the DOM parser and grab all the information I need. So the name, the time, and then all of the latitude and longitude data. Apple Watch takes it every second. Some watches do it a little bit less often, so that's why this page is so long. After we get all of that data, and we've stored it inside of these variables, we can return that data back out from this function on line 23. Something interesting, if you're curious, after we're done, the GPX data is standardized across different watches. So Apple, Garmin, and a bunch of the other big watch providers all have the same name, LE, lat long, track point, track route structure. So it'll allow you to upload from different watches. And watches don't actually store your distance data on them. They use the Haversian formula to do that. And so inside of this function here, I had to figure that out, which was a fun experience during that time, which I can share if you're interested in the QA part, but run a little short on time, so I'm going to keep moving. After we get all of that data, we return that as an object back out to our run form. We're able to set all of that into state, and then we're good to go. Once we set all that into state, up here, we call our post route for our runs, which is here, which has two different SQL situations. There's one for when there's only run data, and then there's another SQL statement for when we're adding GPX data. If there's only a run, then everything from 104, there we go, everything from 104 down isn't going to fire. We're just going to grab all of this information off of the run, store it into our database using db.query, and then send the user their status with that run information. Whereas if we do have GPS data, we're going to go through the database, add all of that GPS data, and then we're going to send them the response. And just so that you can kind of see what that looks like, this is from my dev environment. This is running real, but the GPS data looks like this, super long. There's an individual data ID. It's tied to a user, which is tied to an entry, and then it has the lat long elevation time and created at for that entry as well. Other than that, I think that's it. This is LearningFuze. Thanks for listening to my presentation.
Great job, Cameron. Any questions?
Do you plan on carrying forward with this in that you would be adding other features and benefits to your app?
Yeah, absolutely. So recently I've been really into testing and React testing library in Cypress. But one of the next features that I want to add is on the run card, I want to show users their information for elevation and change. So in here, there might be a menu down here that you could toggle to see like elevation data or track segments where you could hover over it, kind of similar to Strava, and see different segments.
Can you go to a specific activity detail?
What detail? Sorry.
Right here, activity detail. You had that GitHub graph and some line charts. Yeah, I'm just curious, what are you using some sort of package library to help with that, or how did you do all this?
Yeah. Oh, so this is a fun like mapping data structure. So this was all me. I really wanted to, I struggled with map a lot during the program. And so I wanted to create a component that used map pretty extensively. And so the way this works, sort of briefly, is it takes a year and creates an object for every day inside of that year, calls my backend, looks for data, receives that data from the backend for run days and rest days, and then goes through that year and fills in information for the day, whether or not it's a run day, a rest day, or there's no run. And then that's all rendered here inside of these squares. Inside of this, it's a D3 chart. I learned that was real fun with D3, how to use hooks for that, which was cool. And I used a custom hook for resize. On the resize of the chart, getting it to move like this was a real pain, but learned a lot about div refs and that, so that was really cool. And then this is a very like CRUD sort of app where it's just create, read, update, delete with the cards. Did that answer your question? Sorry.
Yeah, great job with that custom graphic there. That would have been very intimidating for me to try and build.
A lot of this was done after the program as well. I think when I finished, all I had was this chart, the D3, the workouts, and the GPX stuff wasn't finished yet. So it's been a long-term process.
You mentioned Cypress. Can you talk a little bit more about your experience with Cypress and what you did?
So I started off with RTL ingest and thought that a lot of my submit functions are inside of my components, and it's really hard to look into components with RTL ingest. So I was looking for a more like end-to-end style solution. I'd used Selenium with Python before and heard Cypress was similar, downloaded it and was like, this is amazing. I am on a Cypress high right now. I think it's so cool how it pulls up the separate menu on your screen and everything. For end-to-end testing, and you can set specific events and look at navigation, and it pulls up the page and there's the time machine. So cool.
So you enjoyed testing?
Oh yeah, probably, yeah.
Good to know. Thank you.
Yeah,
Good work.
absolutely. Thank you.
That will take you far in life.
I wish I would have written tests before for this, but it's in the past.
I think
Just
there
add
is.
tests to any take-home project, and you're above 90%.
And I think we have a question in the comments here from Megan.
Oh,
So
what made you use D3 over Plotly or Nevo? Ooh, great question. So I originally looked at other like really easy to use graphing software. I'm not familiar with Plotly, but I'm a little familiar with Nevo. D3 had a lot of customization options for data points. And so I figured if there was some point where I wanted to make this bigger than just a distance chart, so if I wanted to add in like an on hover functionality, or a feature where the rest days were in there as well, I found in the D3 documentation and in a lot of the D3 stuff that I was looking at that was pretty easy to do. And so that's kind of where I jumped to. But I think other graphing frameworks could also work really well for this.
Cool, thank you.
Yeah, good question.
I think we have time for maybe one more question if there's any more.
I could ask. I'm not sure. It's a really question, but I noticed a lot of the projects are in JavaScript, if not all. Did you guys use TypeScript at all?
We did not cover TypeScript during the program, but it's definitely been on a lot of our radars recently. Brandon and I have been working on it. I know a lot on dual projects. I know Daisy and Anthony have also both dabbled in it. We get like a post-program to-do list check sheet, and TypeScript's pretty close to the top.
Cool.
It's nice. I mean, it can be a pain sometimes with React and different elements, but it definitely learning.
Yeah, for sure. I think just like industry trends wise, I would say it'd be valuable to be using TypeScript or display that value. But I mean, excellent project though.
Oh, thank you.
I want to use it myself. I need to get back into running.
Go for it.
All right. Thanks so much, Cameron. And thanks to everybody who attended tonight. We really do appreciate your support and your dedication to our program. Many of you already know who I am. We're probably already connected on LinkedIn. You probably already have my email address, but just in case, I sent it in chat if you want to connect with me. Or if you want to connect with any of our presenters, again, their LinkedIn URLs are towards the top of the chat as well. So thank you again, and we're probably going to have our next demo day probably in the summertime, so maybe keep an eye out for that. Have a great night, everybody.
You too.
Thanks.
Great job, everybody.
Everyone, that was awesome. Thanks.
All together too.
See ya.
Bye, everyone.
Thank you.
Thank you.
Nice work, Cameron. I like the
Thank you.
hype.
Nice work, both of you. I just can't
Hype.
not be super excited presenting.
I know, you
Yes.
guys did such a good job. I'm very proud of you guys.
Anthony,
You
let's
did such
go.
great
That was
work.
good. Well
No, I
done.
tanked it. If they didn't ask me questions
Nah.
at the end, I tanked.
I thought
You
did
did
good.
not. They asked
did good.
questions. You
I thought you
did
did
well.
wonderfully.
They bailed me out with questions. Luckily, or so. it
You're
was
too
bad.
hard on yourself.
It was bad. It was bad. I'm two
No, dude, you
hackathons
did
this
good.
week. Thank you. Thank you.
You've done 2 hackathons this
Two
week, huh?
hackathons.
Good
I had
job.
one due Sunday, and then I had one due.
Monster.
It was one of the ones that you posted in chat a while ago. That finished yesterday.
Okay. Oh, good. I'm glad you guys are paying attention to that. It's a good way to keep up with your skills. So, well, again, I'm proud of you guys. It's not easy to get up and present your work and do it under like a little bit of a time constraint. You guys did a look, we ended exactly at 7 o'clock. I mean, we can't be much more flawless than that.
I'll be honest. I'm
Amazing.
impressed. I'm impressed.
Yeah, you guys are impressive. Yeah, half the battle is just getting people to know what you guys have to offer, because once they know, then it opens doors. So I hope that these events are really helpful, and if only to give you guys practice in showcasing your work and presenting it to real people, but also who knows, maybe someone takes an interest and connects with you. So let me know if that happens. If anybody reaches out to you as a result, please let me know. So, all right, guys, have a great night and we'll be in touch.
Thank you. Thank you for
Sure.
hosting,
Thank
for
you
putting it together.
hosting.
Oh,
For real.
absolutely. All for you guys.
All right, bye-bye.